All right, welcome back, everyone. We've been looking at this pop quiz while we're collecting, so let's finally get into it. Mike Driscoll makes these. He posts them on his Twitter handle, at Driscoll IS. He also has another one, Teach Me Python, that I believe is in part associated with this. As you can see, he's done more than a few of them. This one's number 77. Tuples are immutable. I picked this one because this evening's program is about Python data types and structures, and we're going to introduce that after our intro here. But before we get going into testing this one out, any guesses from the crowd as to how this one goes? We're saying we've got a tuple. It seems to have some lists in it. And then we're attempting to add to the first position. So the question, I suppose, is that list inside of that tuple mutable? It's possible it is. Or because it's in the tuple, can we not add that to the list that's in the my tuple? And so when we
Is
print
it
it,
a classic gotcha with tuples?
well, it's a Mike Driscoll pop quiz, so it's definitely chock full of gotchas. So we've got A, attribute error. Any takers for that one in the chat? All right, we've got D, says Robert. We've got we've got a B. Gage is saying it might be a type error. And so where
B.
would where would the error come in on that one, Gage? With the type error. Would that be
That was mainly an educated guess.
okay? Daphne says C
Oh no, no.
12534. All right, now Daphne in Python, one tricky bit here. So this is a gotcha. The first position in one of these things with the commas in them, the first position is number 0. So they tricked you. So in this case, my tuple was when we were appending, we're pointing it at that second part. If we wanted to add it to that first one, like in C, it would have been my tuple 0 dot append. And then also we'd still be relying on whether or not you can update one of these lists inside the tuple. But I suspect we can because the list that's inside the tuple, that is a reference to the list, right? And so the list being a mutable thing, we can change that. And since all we're doing is pointing at that list in the tuple, we don't actually have to change the tuple in order to make a change to it. So Dean says it must be option D in that case. So let's go over to a window where we can poke around at this. Sorry for my shoddy screen sharing practices. Zoom has left me with little choice. I can no longer share my slides. It's horrible. So I think I've got this one typed up properly. See, now I can do stuff in the background, no problem. You guys aren't looking at me. Oh, he's looking at the original thing, making sure he typed it right. No problem, because I'm not sharing a portion of my screen. I'm going to edit this all out, but I think this should be all right. And so there we have it, D. So I guess what Mike Driscoll is showing us here is there is a way to edit stuff inside a tuple, so long as your tuple is a tuple of references. And those references are to mutable things, like a list. But if you don't know what mutable means, well, Trevon will be schooling you in just a bit here. Runner says, can you show the error if you try to add that to the actual tuple? Now we're talking. Okay, so if we were to add that to the actual tuple, we would try to do something like this. And so that would maybe put that in this section here. So within the tuple, So we were first we were pointing it at the thing in position 1, which was here, because we know this to be position 0. So position 1, we're adding 5 to that, and hence we get D in such a fashion, 3, 4, 5, like that. And so runners is saying, can we add that to the actual tuple like that? And then I think that should be when we get our type error, right? Because tuples are immutable. Anyway, good one. Let's see how it goes. Oh, there we go. Oh, there's the attribute error.
Okay.
Yeah, because ultimately you're calling the append method.
Right, on the immutable tuple.
Mm.
Good one, runners. So if we had run into what one would expect a tuple issue to be, that being we're trying to change something that can't be changed, trying to mute the immutable, we would have gotten that one. And so
Mhm.
Gage, good call. It would have been an attribute error, but they tricked us. They're just having us change lists from within.
That is super dangerous because you think, oh, it's a tuple. It can't change. It's immutable.
Right.
But if you have a mutable data structure inside your immutable data structure, then your immutable data structure can change.
Tricky Mike Driscoll showing us how to break Python and also possibly just commit horrible war crimes of Python coding. Come on, Mike. All right, enough of that little comedic relief before we get into our data structure talk tonight. This is what we thought data structures and algorithms would look like. Thank you, Reddit programmer humor. All right, it's May 1st, 2025.
Mhm.
How did we get here? One day at a time. All right, tonight we're going to be talking a bit about the building blocks of Python, the currency of the land, and the ways we form it up, aka the data structures. And that tonight is going to be brought to you by the one and only Trevon Babcock. We've got him here from the San Diego group. He also works with the Santa Barbara group, and I know him through a co-op learning group that we have attended over the last few months that just recently concluded. Trevon gave this talk back in San Diego a number of months ago, and so we're happy to see a yet more polished version of it. Once again, Trevon, thanks for having you tonight. I'm going to pass the share off to you.
Okay.
Take it away, sir.
Let's see, send request. Okay, I sent a request.
Oh yeah, that was for multiple presenters, so this might get extra exciting now, but you should be able to share now.
Okay, is it sharing?
I don't see it yet. It should,
Oh, I see. Okay, just a
yeah,
second.
click the button, and then it think, yeah.
Yeah, okay. So, oh, I'm sharing my whole screen here. How do I cancel out that? Stop share. Sorry about that. Let me do
That's
that
okay,
again.
we'll edit that out.
Yeah, so it looks like this one. Share.
Oh, perfect.
Okay, good. Great. Okay, so let's get started here. And okay, hello everybody. Good to be here. Thanks for having me, Woody. May I present Python's core data structures and this handy table showing their behavioral characteristics. A quick reference to compare data types while you're working with data and designing programs. Feel welcome to comment during the presentation. Each topic will conclude with 3 dots on the bottom of the slide to give everyone a chance to discuss anything. Okay? A data structure is a way of organizing and storing data to facilitate data access and modification. Data structures are also known as data types or just types or objects. They are fundamental building blocks of the programs we create and maintain. We'll focus on lists, tuples, Oh, wait, I think I got on the wrong slide here. There we go. Sorry, we'll focus on lists, tuples, dictionaries, sets, and strings. Okay, these are the simple types, aka primitives, scalar types, single value types, or atomics, as you see here, which also include single string Unicode characters. Okay. So mutable means an object can change. Elements can be modified, added, or removed. These highlighted are immutable. They cannot change once created. Immutable and hashable are related. Hashable means an object's hash value does not change over its lifetime. An object has to be immutable to be hashable. Hashing converts an input into a fixed size numerical value, a hash value, indicating the index where the data is stored, which makes lookups, insertions, deletions, and membership testing fast and efficient. How do you determine if an object is hashable? The hash function. Immutable hashable types include the simple types and dictionary keys, frozen sets, strings, and tuples if all the elements are immutable. Value types, ordered, duplicates, and indexing refer to the individual elements inside a data structure. So set elements, for example, must be hashable. They'll be in any order, no duplicates, nor can values be accessed or sliced by index, like sequences. I'll give you a moment to compare how each type is similar and different. Think about how you would use this table. I need a data construct to something. It should have the following characteristics. ... Which columns should be checked? Which rows meet the criteria? Feel free to comment if you have anything to say.
All right, so that the tuple thing, we worked on tuples in the pop quiz, right? And so you were saying, as far as hashability goes for tuples, it's only if the elements of the tuples are immutable.
Yeah, I'll have a precise explanation real quick here.
Right.
So I'm going to build up to that.
Gotcha.
Okay, so I'll be right. Let's see. I need to get to this here. Okay, there we go. Okay. Data types can be truthy or falsy. So if we convert an object to Boolean, it will evaluate to true or false. That's the question. Will it evaluate to true or false? So we're really checking for non-zeroness or non-emptiness. Truthy values evaluate to true, i.e. not falsy. Data types that are empty or zero are falsy, as is the none type. Everything else behaves truthy. Here, list A has no elements. List B contains an element, so it evaluates to true. And we'll truth test this single element, integers 0 at position 0, which evaluates false. Okay, so a list is a variable length ordered sequence of comma-separated mutable values of any type enclosed in brackets. Lists are our most versatile data type. There are many ways to create lists using explicit values, comprehensions, concatenation, and repetition. We can also use the list function, which takes iterators, sequences, collections, and generators. The list function is mostly used to convert existing data into lists, into a list. Here we turn a string into a list. Here, list A has various data types and duplicates. Let's append a tuple. So we appended a tuple to a list. Lists are not hashable. We pass A to the hash function and get a type error. Use cases include converting data when data needs to be modified frequently and storing duplicates. Now, as you see, there's 3 dots if you'd like to make a comment or anything like that, since we're on the subject of lists. Okay. Okay, tuples. Here we go.
We're back.
Tuple is an immutable sequence of comma separated values of any type. Parentheses are optional, but some situations require them. They are very similar to lists. Let's create a tuple. Single item tuples must have a trailing comma. For me, tuples are more readable with parentheses. The tuple function can construct tuples or convert iterators, sequences, collections, and generators into tuples. Here's another way to construct a tuple. The typical use case is constructing a tuple from another data type. Let's convert a string to a tuple. This tuple A includes a nested list. We try to modify the second element and we get a type error. However, if a value is mutable, such as this nested list, you can manipulate it in its slot. Here we append a value to our list inside the tuple. So a tuple is not mutable, but it can contain mutable objects.
Well, there we go. There's our pop quiz, basically.
Yep. But a tuple isn't hashable if it has a mutable object. We'll get a type error. Okay, see our list inside there? Okay, tuples cannot be modified. Here we have a tuple, then create a new tuple and replace it using augmented assignment. As you see, a new object was created. Or we could convert it to a list, modify it, and then convert it back to a tuple. Use cases include when data should not change, for example, coordinates or fixed configurations, as dictionary keys or set elements, or returning multiple values from a function. Oh, I was going to give you guys a chance to comment if we're on tuples there if you want. Okay. So dictionaries. A dictionary is a mutable object that maps hashable keys to any data type. It contains comma-separated key value pairs where the input is mapped to the output. enclosed in curly braces. Dictionaries became ordered as of Python 3.7. Dictionaries are also known as hash tables, maps or mappings, hash maps, lookup tables, or associative arrays. A key is a unique immutable identifier, like a scalar, single value type, or tuple if its objects are immutable. That links to a value. Keys are hashed, allowing for very fast lookup. So you look up a key and we get a value. Values can be of any type. Keys nor values are indexed, and there are no duplicate keys. There could be duplicate values. There's two ways to create a dictionary, the dict literal and the dict function. The dict function can handle iterables of key value pairs, keyword arguments, and zip objects. There are two ways to access values. The get method avoids a key error if no value is found. Use cases include storing structured data like JSON-like objects, fast lookups, counting occurrences like a word as a key, and count as a value. Okay, so that's dictionaries. If anybody has a comment real quick.
I got a question on the dicts. I'm not familiar with the zip. What was the
So a
reference to
zip
that?
is gonna, yeah, it can take like two lists. Let's say just A, B, C, and 1, 2, 3, and it's gonna put those together like in a dictionary. So
Oh, okay.
A with the value 1, B with the value 2, etc.
Okay.
And then you
Thank
could also switch those around.
Okay. Thank you.
Yep. And yeah, zip
Good
is
one.
a cool function. So thank you. Okay, so let's talk about sets. A set is an unordered collection of unique items of any immutable hashable type, enclosed in curly braces. Elements are also referred to as keys. A set is kind of like a list, except values must be hashable. Values are unordered. Sets do not record element position or order of insertion. No duplicates and no sequence-like behavior like indexing or slicing. The set itself is mutable. We can add and remove items. But the keys must be immutable because they're turned into hashes. So way faster lookup compared to lists. These are the immutable hashable types, as you see highlighted here, except the tuple if it contains a mutable object. So wink, wink, special case. Okay, use cases, storing unique objects, removing duplicates from sequences, membership testing, and performing math set operations to compare data types or types in various ways. There's two ways to create a set, the set literal. Here we have the curly braces and the set function. Oh, what do we do here? Okay. Both can construct or convert sequences.
You have a typo.
Oh, where's that?
It's line 2. So you
Okay.
have set ABC, and then you have set open parentheses, and then open parentheses A comma B, close
Oh,
parentheses,
yep.
and then close brace.
Yep. Thank you. Good job. Yeah, so that's supposed to be a parentheses on the end there. Yeah. So we're looking at that tuple on the second line. Thank you. Okay, so we got the sequences, iterators, and generators. Thank you for that. Okay. 4. Sets have no order. So if you want to make up some new words, you might try sets. Okay. The usual case is to pass a variable representing some data, say a tuple, and we get an unordered set with no duplicates. Best practice is to use the set function. And maybe use the set literal for making quick little sets from scratch, but it looks like a dictionary, which can be confusing. Let's pass in a dictionary to the set function. Only the keys were passed. Let's pass in a tuple containing a nested list. Get a type error. Lists aren't hashable. Okay, strings. String is an immutable sequence of Unicode characters enclosed in single, double, or triple quotes. Each element is a single value, or a single character, excuse me, a Unicode point.
So when we do things with strings, we change letters. It's immutable. So we're creating a new string based off the changes with the old immutable string. Is that right?
Could you state that one more time?
Well, so sometimes you can handle strings like lists. So if I said A and then in square brackets, I put the number 1, it would spit out Y, right?
Mm-hmm.
And so I can change that, can I?
I think you would have to create a new object.
Well, yeah, and then I think that's maybe the point I was getting at. It's like when you do things like that, you're not actually changing the original string, you're just creating a new one.
I think so. Anybody else have a comment on that?
This would be a good one for DN, but he's unfortunately in the middle of persimmon season, so
Oh, yeah.
yeah, he would
What
normally jump
season?
in here. It's persimmon season down in Auckland.
Oh, well, then that totally makes sense.
Yep.
Yeah, so he's working the grounds.
But they
But
say it a little different down under, right?
oh yeah, they say everything. It always sounds way cooler than when I see it, whatever it is.
Right.
Yeah.
Right.
But when I look at strings, sometimes I see like a letter in front of the double quote.
Oh, you mean like a D or an R, like a raw string kind of thing?
Yeah.
And isn't there a D also? Something I don't know.
So there's a R for raw string, there's F for F string, and
Yeah.
there's B for
B.
binary,
Yeah.
right?
Bytes.
Or sorry, bytes.
Yeah.
Yeah.
Uh,
Yeah. Thanks for bringing that up. Good job. Okay, so creating strings. Basic. We can even concatenate strings. Okay. The string function takes numbers, byte-like objects, and objects implementing the string dunder method, which includes most objects. The string function is a helper that looks to the string dunder method to say, convert something into a string. Once we define a string, it cannot be modified because it's immutable. Strings are hashable. All the more complex data structures discussed here have their own methods and functions. You can do a lot with string methods. Looks like we have probably like 40 almost 40 string methods here. Plus we have the dunder methods. And these are all the functions that can be applied to strings.
Amazingly, when people make websites, they don't use the strip method, which which is insane. You should always strip the beginning spaces at the beginning and the end, so you don't get this weird effect where it says like, oh no, that's not valid, and they go like, what? That should be fine. Um, and then you figure out that it didn't strip the spaces at the beginning and the end of your password or username or whatever.
Cool. You do web
I
stuff?
do. Yep.
Cool. All right. Thank you. Yeah, I'd like to get in web myself. Haven't gone there yet though. What's your framework that you use?
So I use Flask. Now I use Fast API. Fast API can be used to make websites as well.
Yeah. How's that?
It's pretty good.
Cool.
Um, so right now I'm dealing with, so I want to have like a voice interface, right? So I have a Fast API script that figures out the microphones on the user's system on the remote browser, and then takes a recording of them saying something, sends it back to the server, uh, takes a transcript of that, and then figures out what the appropriate action is based on what they said.
Cool. So, and then what library do you use to like voice recognition or word
Whisper.
whisper? Okay.
Yep. Yeah. So Whisper is
Nice.
both something you can install it locally, and also you can use the cloud. You can actually have it do the heavy lifting in the cloud, right?
Mm.
And OpenAI. Um, and so initially, I set it up to do Whisper on my own machine, but when I tried to do it on a cloud system, like a $5 cloud system, that doesn't work. So I had to switch it to do the actual transcript in with the OpenAI API.
Yeah, actually, I thought of
And
asking
it
you
works
that question.
perfect. And it costs nothing to use it like 100 times.
Cool. That's awesome. Sounds like a blast.
Yep.
Okay, so we got through the use cases here. I think storing and manipulating text data, processing input output, and pattern matching with regex. So, okay, so let's talk about efficiency. All right. Okay. Say we have 100,000 users in a list. To search for a name, you have to search item by item. If it's near the end, it's going to take longer. On average, you have to search through 50,000 items to find a match. With a set, the item is found instantly. So the set offers an incredibly massive efficiency gain. Let's see, let me back up here. Anybody have a comment on efficiency? That's pretty awesome, though. I mean, it's so fast that it's amazingly fast. Okay. So,
JP says stats were more useful than originally thought when they started learning. JP, do you want to unmute and talk about that? Seems
feel
like
free.
that. All right, carrying on.
Okay, carrying on. So when you're thinking about some data, its characteristics and behaviors and data structures, some questions you can ask are, will the data be changing? Do you want a mutable or an immutable data structure? What data types will you be working with?
It depends.
Do the items need to maintain order? How will I handle duplicates? How will I look up, modify, add, and or delete items? How big is this data? Does memory usage matter? Does anybody have a comment about memory usage? I actually don't know too much about that. I mean, once we load a list into memory, it's only, I guess it depends how many.
Yeah, I hit this practical limit fairly frequently. If I have like a pandas data frame with like 100 million rows, yeah, I can easily exhaust the memory of my Python virtual machine.
Hmm.
So there are tricks like, you can chunk it out, process it in chunks. Each chunk can fit comfortably in memory. That's a common strategy that I use, and others use that too.
Yeah. I'd say something that's useful when you're looking at data structures like that is you say it uses more memory. Well, how could you measure the amount of memory that one approach uses versus another approach uses, right? And same thing with time. How can you see how much faster it is? Um, and
And
I
we
don't
could,
remember the method off the top of my head, but with like ChatGPT or Claude or something, you can say like, oh, how can I time my function? And that would be that would look good alongside those tables to see like, okay, well, when I ran it using this data structure, it took this long.
yeah. Well, there's time it, of course. Oh, what happened here? I don't know, my screen just disappeared. There it is. So, of course, there's time it. I think measuring memory is more difficult. I don't know. Does anybody know how to measure memory?
Um, that should be a ChatGPT question, right? Um,
Yeah, I don't think there is anything. I think actually DN has been working on this. And as I recollect, he said that it's difficult. Uh,
um,
so as far as speed and time goes, let's see if I can look at this thing. Speed and time. For some reason, I can't open my documents. Well, anyway, we can talk about it later at the end. How's that? Because it is interesting. Okay, so let's go on here. Let's see. So let's see. Next slide here. God.
And so JP finally chimes in. Had to clean up data at my job, and creating a set to cache elements essentially reduced the algorithm from O of n to O1. With that specific use case, it reduced the compilation time from 2 minutes to 4 seconds. Yeah, that sounds like a scenario that you'd feel. 2 minutes is not the end of the world, but if you've done that a few times and all of a sudden it's 4 seconds, yeah, it's pretty good.
Especially if you scale up, right?
Yeah, exactly.
Yeah.
Dean is off. We missed him. Farewell, Dean. Who Robert sends us a nice, is that a screenshot or is that a link to the thing? Oh, a screenshot to how and when to talk to AI. Yeah, get saves of simpler. That's what I got to.
AI is perfect for things that you don't use all the time. It's kind of like, wait, how do I do that again?
Yeah,
Um,
absolutely. And things that you're fairly certain are possible. It's likely there's some coverage there.
yeah. So I think Pimpler uh, is probably the cooler way to do it because it sounds like pimp.
Yeah, definitely. But it's probably more difficult because pimping ain't easy.
That's true.
Okay,
We digress.
I'm going to conclude here. As we've seen, Python's core data structures, lists, tuples, dictionaries, sets, and strings each have their strengths and best use cases. Whether you need ordered sequences, immutable collections, key value lookups, unique elements, or string processing, data structures are the tools to manage data efficiently. The choice of a data structure can make or break your program's performance, readability, and scalability. A simple switch from a list to a set or from a tuple to a dictionary can optimize speed, reduce memory use, or enhance code clarity. In addition to this table, there are many more specialized data types. What's the time when choosing the right or wrong data structure made a difference for you? Do you have any tips about approaching data or any other comments? Thanks. That's it, guys.
Nicely done.
Thank you.
All right. So, any other anecdotes of? Yeah, good job, Trevon.
Thank
I
you.
agree. Diane says good job.
Thank you.
Cool. So, do we have anyone here that is just getting started? Maybe we can talk a little bit about why this was important, because this is like how things move around in Python. These are the game pieces on the board, so to speak.
I haven't like started, but it's been a super hot minute, if that counts.
Sure. So, where are you kind of directing your search as far as like why to get back into Python and what you'd hope to do with it?
Well, I've been an analyst for 6.5 years, and I know that Python is the main language when it comes to statistics and mathematical equations, like, pandas and PyCharm and all of that. Um, so
Absolutely.
I need it. Yeah. So I need it for that, and I need to show potential employers that I kn that I'm capable of being a good analyst. I'm fluent in SQL and fluent in also with Excel, which isn't a programming language, it's something different, and also Power BI, but I know that I can do a hell of a lot more making my own code in Python versus like using the pre-programmed stuff in like Tableau and Power BI.
Sure.
Hmm.
Now, if you have access to Tableau, I would say that maybe don't completely turn your back on it, but definitely p- something like Tableau with Python in the mix is something of a super combination. Gives you some pretty superpower-esque skills to bring to the table. And now you're an analyst. We talked a little during this meeting about APIs. I would point out a data type in here, the dictionary in particular. A lot of APIs are going to be passing data along in a data structure type called JSON. That's JavaScript Object Notation, which is effectively a dictionary. And so I would highly recommend starting to look into the APIs for the different types of data that you're looking for. I don't know your particular industry, but by and large, you should be able to find an API, application programming interface for the uninitiated.
I don't have an industry. I'm unemployed.
Okay, well, if you're an analyst, and you're unemployed, this might be an interesting time to apply some of your analyst skills. Analyze some markets, see where things are going, and maybe start to try to model them and figure out what's next for us. Where did you used to analyze?
Mainly sales data. I can't speak. I'm sorry.
Sure.
Mainly sales and also test results. I used to work at a marijuana testing facility. So I was like their so-called tech guru, and they thought I was a genius just because I knew how to do inner joins in SQL, which was the programming language that was used by our LIMS system, which is a laboratory information management system.
Nice.
So I'm like going from like impressing people with something so simple to going to meetups with actual programmers and feeling like a huge imposter.
Well, I will tell you that never goes away. I feel like a huge imposter more often than not. But don't let that discourage you. I think that's maybe a factor of as you get into building things and you start to get your first points of traction, and then all of a sudden have this responsibility to keep some application or set of scripts up and running for a team or a whole community that's expecting it, you start to realize, oh, it becomes very valuable to say no early because you've got in your head all these things you need to do to make that thing better or to extend what it's doing or answer some real problems that are being recognized. But you're also getting a whole bunch of feedback from people who are understandably gotten to a point where like what you've made is instrumental and they've got a bunch of ideas and you want them to feel heard, but by and large more of what they're saying is like something you want to be like no, not really. And so I feel like that's where some of the default attitude from a lot of engineers comes from. Is like there's infinite things we could do at any given time, but the fact of the matter is like I can't work on every single request because by and large, well, sometimes it's coming from people who don't know what's going on behind that.
I have a
Well, I
question.
used to get from my C-level executives, they would ask for requests that were like impossible. I'm like, I can't interjoin these tables because there's no common key.
Yeah, yeah,
But
yeah.
I mean, SQL is a completely different language.
Yeah. Yeah, but hey, if you know SQL, that's great. No, understanding relational databases is a total virtue. Hey, Steven's on the video. How's it going, Steven? Got something for us or just showing off your awesome scarf?
Oh yeah, no, I didn't realize I was on camera. Yeah, hi all. Yeah, sorry, I was otherwise engaged. I didn't catch most of Trevor's talk, but yeah, I was thanking Michelle. Kaggle is fantastic. Recruiters spider it a lot, and it's got lots of like really accessible data sets and courses and stuff. So
I'll post a link to
like,
that, Michelle Kaggle he's talking about.
say it again.
I was just translating what you said so that it is, she knows it's in chat. Kaggle, that is.
Yeah,
Yeah.
Woody, I had a quick question for you. There's a request for a link to this
That was me.
to the presentation. Do you have a link for us?
Oh yeah, that's right. Did you send me the slides? I can
Yeah,
host
I
it right.
did.
Okay, I can host it right now. I'll have it in just a moment.
Okay.
Cool. Yeah, I mean, my comment to Michelle was if there's anything specific you want to be looking for a SQL data set, anything in particular, sales forecasting, email response, tidal wave, astronomy, anything. What is it you would like to work on? Michelle, if you're there. Muted.
Yeah, Michelle, when you get a chance, we're wondering what are you aiming at next? Maybe we can get a few steps lined up for you from where to go.
Yeah,
I'm just trying to land like a analyst role again. Or apparently I also have a knack for project management because I'm pretty good at translating tech speak to non-tech speakers. But I know that product manager or project managers are usually the first to get cut if there's ever a layoff.
Sure, but I was trying to say, when you say analyst, do you mean stock market, inventory, financial, biotech, anything like what sort of data set?
Consumer data sales, right?
Mainly sales, and I worked in a marijuana testing lab, so I'm also familiar with like test results. So also like I could probably do biotech too.
Very
Um,
cool.
I definitely feel more comfortable in the financial sector. Because I taught myself Python back in 2018. And prior to that, I taught myself JavaScript, which made Python seem super easy in comparison.
Yeah.
It's just I haven't used it.
Yeah. Michelle, I would if you could take a look at the two links that I posted.
Hmm.
Um, the people I work with would probably be a good help.
Are you talking about Kaggle?
No, I posted the Kaggle stuff. Robert posted the company link. I'm Steven. Robert is the other stuff.
Oh,
So,
okay.
what do you do, Stephen?
And data science, I'm in San Jose.
Yep.
In the exotic space, I do like natural language processing, sort of document parsing for things like patents, biotech, that sort of stuff.
Could you post your Kaggle link?
Do you mean stuff I've competed on, or have?
Um, so every Kaggle account has like a project page, right?
Yeah, yeah. I used to be super active on Kaggle, and they wiped your stuff if you're not. So I haven't done
Oh
anything
wow.
seriously
Okay.
in a couple. Yeah, they had a giant purge a few years ago. So I mean, I'll post my link now, but you won't find much on it. But I'm always interested in teaming up with which of you guys use pandas and which of you guys use folders. So I'm definitely interested in learning folders.
I'm sorry, I didn't hear exactly what you said there.
Do all of you guys use pandas and which of you guys use folders? I'm definitely interested in learning folders and doing something as a showcase to learn folders. Which one of you?
Okay.
Which of you are using folders
I'm
in
using
production?
folders.
In production or for on the side?
On the side at this point, but probably moving into production pretty soon. Um,
Okay.
So what do you think about polars? I mean, do you still use pandas a lot, or have you kind of just switched over to polars?
I use both because a lot of times the if you're using an existing project, it's structured to use pandas, and then you have to deal
Yeah.
with. I mean, they're not unreasonable changes, but it's easier just to leave it as pandas if you're not dealing with a lot of data. If you're dealing with larger files, uh, if you're starting a new project, it makes a whole lot more sense to start off with polars now.
Yeah. Yeah, I mean, what they say, like if you're doing a query that's fast in columnar, so like, whatever zip code or name or whatever, really fast filtering, stuff like that. Has anybody touched any of those Kaggle competitions in the last 6 months?
Uh, so my co-founder has done like a lot of Kaggle competitions, but he hasn't been doing that in the last few months.
Okay, so I mean, they have a getting started, they have a store sales time series forecasting. I don't know, Michelle, that might or might not be useful. Anyway, this is like a rolling leaderboard forever. It's pretty well defined one. Don't know if there's anybody's interested in that. And then they got a lot of more leading edge stuff. So, AI, whatever. AI, biotech, stuff like image mapping. James Street real-time market data forecasting has 2 months left. Does that interest any? And if anybody's interested in that, hit me up. Okay. No takers. Okay.
What was that?
James Street real-time market data forecasting. I'll just post it.
Yeah. So, Stefan, are you involved in any of the AI groups over in the Bay Area?
Yeah, a couple, yeah. Uh-huh.
Okay. Yeah. So my so I'm part of the Fair Oaks AI group here
Okay.
in the Sacramento area.
Oh,
And so
there's a Fair
our
Oaks and
discussions pardon?
there's a Fair Oaks in Sunnyvale too, so that's maybe confusing. But okay.
Yeah, Fair Oaks, like next to Folsom.
Yeah, there's a Fair Oaks in Sunnyvale. That's the only Fair Oaks I know.
Right.
Okay. Sure, yeah. Okay.
Yeah, I'll send you a message on Kaggle, but we talk about both the AI side and kind of the data science side, right?
Mm-hmm. Anything in particular?
Um,
NLP, text, image, audio, speech,
yeah,
translation,
so like
video, all of it.
yeah, so NLP, obviously we're working with translations and mapping voice input to
Uh-huh.
both to API endpoints and
Mm-hmm.
to um, uh, 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 browser sequences, right? So what we want to do is we want to vo have voice control of a browser.
Mm-hmm.
So that's
Uh,
using an
um,
LLM.
I'm sorry, for what? Voice-driven search or how?
So it's an assistive device, right? So
Say it
if
again.
you it's an assistive device,
Okay.
right? So if you
Uh-huh.
have people who either they broke their arm or they have unsteady hands or they have
Yeah.
one of a
Mm-hmm.
number of different type of medical conditions, right?
Okay.
When you try to do a very hand motion intensive process, and
Yeah.
like the Kaiser Permanente website is an example
Yeah.
of that, right? You're doing a
Yeah.
lot of clicking on different things,
Yeah. Yeah. I get it.
and if you have tremors or whatever, it's very difficult. So we want to solve that
Yeah.
problem through a voice visual interface. You don't necessarily want to have the output as voice. You want to have
No, I
voice
understand. Yeah.
input, right? So yeah,
Understood.
that's what drives our work.
Right. Assistive voice input to navigate a website.
Yep.
So
That's
that
good.
would be considered an accessibility project, right?
Yeah, I guess you'd classify it as an accessibility project.
Nice. Are you doing any eye tracking?
Um, so to do eye tracking, you would
It's very
either have to
difficult, I
use
understand.
you'd either have to use you'd have to have a camera,
Yeah.
right? Or you'd have to have some maybe like head-mounted device to
Yeah.
track the eyes. We haven't, I mean, we haven't examined that route. We've focused on the voice input route.
Nice. Yeah,
Yeah.
that's a lot more reducible because microphone and it's time series data versus, yeah, eyes are crazy. That's cool. Is that an extension of the NVIDIA hackathon win? The Startup
Yeah,
X thing?
yeah. So the
Nice.
NVIDIA hackathon was we want to. There's an existing API, right? And um, we want to call different API endpoints based on voice input. Um,
Right.
but now to actually, but until you actually have the API for the thing that the website of interest, you have to use a browser automation.
Right.
Um,
Yeah, what are you using? Is that where you were talking about Puppeteer?
I was looking at Puppeteer and uh, Microsoft Playwright is actually a more powerful solution.
Yeah, that makes sense. That's cool. Well, nice. Well, I think that is probably about good for tonight. Thanks again, Trevon. I've posted a link to the presentation in the chat. I'll also link it in the YouTube when I publish that. But unless we've got some announcements or from anyone, I think we may have exhausted our presentation for tonight. So Thanks, everyone, and we will see you in a month.
Bye bye.
Bye, everyone.
Cheers.
Bye.